Normal incidence reflection 12.1, we're going to take what we've learned and generalize it and look at waves interacting with boundaries now. So we have two materials, material 1, material 2, properties, mu1, epsilon 1 prime, epsilon 1 double prime, and the same for material 2, indexed by 2. But you say, well, what's this? Well, we go back to what we did for conductors, epsilon minus j, sigma over omega, and taking that as a cue, the book says, well, what if we don't have a conductor, but we still have some, if you like, loss terms, so we write it like this. So that's where epsilons come in, and that means we can handle things and boundaries and materials that are not necessarily conductors, but have a real and the imaginary part for epsilon effective. Now, given epsilon effective, Sam, what is our characteristic impedance for either one of these? Pick a number, 1 or 2, whichever you like. We'll only write for one of them.
Oh, okay.
So
then, well, we start with mu at the top again.
Yeah.
And then epsilon effective.
Yeah.
So we write in, do we write in the new notation?
Yeah, new notation.
Epsilon prime.
And
if only we had more letters to use, right?
So put a 1 or a 2 there so we can always keep in mind that we're on one side of the boundary or the other. So there we are, and the same for 2. Now, if we think of transmission lines, when we had 2 transmission lines joined together and their characteristic impedances were different, we know that from transmission lines a wave would come in, hit the join, and reflect back. So let's start thinking about this and modeling what actually happens. So here we start with the wave coming in, E1 plus and H1 plus. So it's going into the boundary. Now, we get transmitted through E2 plus, H2 plus, and it's going in the same direction. Is that enough, Sam? It's missing something?
It does look like we're missing something. When in transmission line, didn't we have things going back?
We had reflections, so let's put that in. E1 minus, H1 minus, and it's going back. Another thing that's missing in this is the y-axis.
Mm-hmm.
Do you want to show the y-axis, and then you can write it in?
Well, we can do a simple right-hand rule, right? So x cross y is z. We do x cross y is z. So y is coming out of the page.
Yeah, y is coming out of the page, so I'll put a circle with a big dot. So it's coming out of the page.
Looks great.
Okay, so we got that done. Now we have to say something about the vibrations or the directions of the field in this case. So the x, the electric field plus is going in the x direction, and the same here. So E2 is going in this direction. And we know that H coming in is in the y direction out of the page. So there's H coming in. And going through, same direction, relatively speaking, it's that one. Now, E1 is still parallel, and that's from transmission lines, right? Remember the voltage reflected same way. So we have the voltage that way. But what about reflected current?
Well, if the direction is traveling that way, then the reflected current would, E is that way.
Yeah.
And then it's traveling that way.
Yeah.
Then you have, right hand, left hand.
So it's, take your,
oh, there we go.
yeah. So there it is. So now,
so H field gotta be pointing into the page.
into the page. So remember what that was in transmission lines? The way we did that for the current was what?
Well, we add a negative sign to reverse the direction, right?
Yeah. So here, the ratio of E1 to H1 is given by the impedance, and the same here. But when we do the ratio for E1 minus and H1 minus, what do we get?
Then we have minus E1 minus divided by that.
Yeah, so H1 minus is going to be E1 minus divided by eta 1. The whole thing, that ratio, with a negative sign in front, just like the reflected current in transmission lines.
That's
And
convenient.
now, let's write all that, summarize all that now. So we get, let's look at the phasor notations for everything, just the notations. We're not doing any of the math here. This board is just the setup board. So we have EX1S or S1, XS1. So X component, phasor form, material 1 plus. And then we have HYS1 plus. And then we have EXS1 minus. And we have HYS1 minus. And then we have E plus XS2. And we have HY plus S2. So those are the 6 quantities that we have to write out. And this is going to be quite a bit of work. I want to say something about this, is that we know what this is. And what we will find trouble with is the amplitudes of this and this. So there will be 2 unknowns, and we need 2 conditions. And so we're going to see what those conditions are. Then we're going to set up the equations, and something marvelous is going to happen. So let's have a look at what these equations are. And Sam, would you like to erase the board?
I would like to erase